I'm very pleased to be back here at Ohio State. I consider this is my alma mater, and it's like coming home. Just to amplify a little bit, I consider myself as an atmospheric physicist. I've been involved with the atmosphere now for about, let's say, 60 years, maybe a little longer. Years begin to mount up after a while. And I've worked both in experiments and in theory. Somewhere along the line, I was tapped to set up by the U.S. government to become the first director of the U.S. Weather Satellite Service. We set it up in 1962. And it's worked very well, and it's a very good program. I've had other federal jobs since then, but I can tell you that none of them have been as good as the one where you can actually set up a program. It's difficult these days to do anything in government.
We're up in Worcester here.
What I thought I'd like to do today, two things, basically. I want to convince you, first of all, that the science related to climate change is not settled. It's not settled. There are many scientific problems that have not been solved. I don't pretend to have the solutions. I don't know what they are, but I can outline for you what the problems are. And if you hear people say the science is settled, they must be smoking something. It's not. And the second thing I want to do, and perhaps that's more important, is to try to convince you, if I can, that the climate changes that we've been seeing in the last 100 years, particularly in the last 30 years, mainly in general warming, are caused by natural factors and not by human activities. That's going to be a little more difficult, but I ask you to think about it for a moment. If you look at thermometers and take readings and plot graphs, and you see the temperature going up, you ask yourself, what's causing that? Is it natural or is it man-made? Well, it could be either one. Both are plausible. We know that in the past, climate has warmed and cooled and warmed and cooled. So if it's warming now, it could be natural. On the other hand, we know that human activities are generating carbon dioxide, which is a so-called greenhouse gas, which would produce a warming. So human factors are also plausible. It's a difficult scientific problem to distinguish between the two and to decide which is the real cause of the current warming. I hope to show you some of the data, and I'm very data-oriented. I believe in observations. Some other people are less data-oriented. They believe in climate models. Well, the climate models all say it's warming, it should be warming because of human activities. But the models cannot be trusted because they are only imperfect representations of the real atmosphere. The atmosphere is much more complicated to be captured by a single model. I'd like to show you that. So that's the purpose of my talk here today, to convince you, first of all, that there are many scientific problems that are still unsolved. And the most important one, the single most important problem has to do with what is the real cause of current climate warming, or the warming of the last century. Is it natural or is it human? Of course, we believe it's natural, but there are others who believe it's human. So there's a scientific controversy. I don't suppose that I'm going to settle the matter for you here today. That would be asking too much. On the other hand, if you have the time and inclination and are really interested, I invite you to read this report, which is called Nature, Not Human Activity, Rules the Climate. It's available on my website, which which is www.sepp.org. I should say a few words of introduction. I know that many of you are working on problems having to do with the environment. But the environment is a big, 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 big catch-all. Climate is an important issue. It's part of the environmental issue. But since I assume that you're not specialists in this issue, I want to say a few words of introduction, particularly about the so-called greenhouse effect. You all know, of course, that the important energy source is the sun. The sun heats the earth. The earth becomes warm and then radiates energy back out into space. And there's an equilibrium, a steady state. The incoming energy must balance the outgoing energy. The incoming energy from the sun is in the visible region, the so-called optical spectrum. The outgoing energy is in the infrared. You cannot see it. Our eyes are not sensitive to the infrared. Well, if that's all there's to it, life would be very simple. And unfortunately, there would be no life because the earth would be very, very cold, much colder than it is today. But the earth is not cold, it's warm. Life flourishes on the earth. And the reason for this is the so-called greenhouse effect. The greenhouse effect consists of having some gases in the atmosphere, mainly water vapor, but also carbon dioxide, methane, and a few others, that are called greenhouse gases. And what they do is they absorb some of the heat radiation leaving the Earth's surface and re-radiate it back to the Earth, and then, of course, out into space. And this re-radiation back to the Earth, the back radiation, is the greenhouse effect. That's what really keeps the Earth warm. That's why we have plants and animals and people. The greenhouse effect is real. The increase in greenhouse gases in the last 100 years is also real. So the question is, does this increase in greenhouse gases cause an additional warming of the Earth? That's the $64,000 question. I don't want to put a number on this, but that's the important question, and that's disputed. That question can only be settled by looking at evidence, because, as I told you earlier, both possibilities are plausible. It could be natural, it could be human. One has to look at the evidence in some detail. That's not an easy job. That requires a lot of scientific finesse. What I'll try to do is to introduce you slightly to the problem. It's a vast problem. And since it's disputed, it becomes very, very detailed. But I'll introduce you to it, and you should be able, after listening to this discussion, walk away and say, gee, I don't know what's going on, but it could be either one. I don't think that you will be convinced one way or the other, but at least I want to convince you that the science is not settled, that it's still an open question. So let's look at some of the scientific issues. I have picked 8 issues. Why 8? Oh, no particular reason. I guess I ran out of space. There are many, many more. But these are the ones that I'm interested in and happen to think are very important. The most important one is number 1, the so-called climate sensitivity. What does the word mean? Climate sensitivity tells you how much warming you will get if you double the amount of carbon dioxide in the Earth's atmosphere. If you've been reading newspapers, journals and magazines, you probably know that carbon dioxide, since the beginning of the Industrial Revolution, has increased by about 40% over its ambient value because of human activities, we believe. Even that's disputed by some. But let's grant that. Let's grant that the burning of fossil fuels generates carbon dioxide, we know that, that's sure, and that is responsible for the observed increase in carbon dioxide. So climate sensitivity is a measure of how the climate changes as a result of an increase in greenhouse gases. Specifically, climate sensitivity refers to what happens to the climate if you double the amount of greenhouse gases like carbon dioxide. Okay, the two answers you'll see there. One is 3 degrees. That's the answer given by the IPCC. Now, I'll have to explain what that is. IPCC is a group of scientists pulled together by the United Nations. It stands for Intergovernmental Panel on Climate Change. They've published a number of reports, and they try to tell us that if CO2 doubles in the atmosphere, the climate will warm by, on the average, around 3 degrees Celsius. However, there's another point of view of a group called the NIPCC, which some people say it means not IPCC, never IPCC, but actually it stands for Non-Governmental International Panel on Climate Change. I had something to do with setting it up. I've been deeply involved with it. It is entirely non-governmental. It's made up of very competent scientists from all over the world. And essentially what we have done is to examine the same evidence that the IPCC has examined, that is, published papers in peer-reviewed journals, some of the same papers, but we reached a different conclusion. Our conclusion is the climate sensitivity is only 0.3 degrees, or maybe even less. Big difference. That's a factor of 10. If the climate sensitivity is only 0.3 degrees, it means that the increase of CO2 is irrelevant to climate. It makes a little bit of difference. You barely measure it, but it's irrelevant from a practical point of view. And it also means, from a political point of view, that any attempt to control the emission of CO2 is pointless and very, very expensive. So it's obviously a very important question to settle the question of climate sensitivity. And I'll be spending a lot of time discussing that because it is the important question. The next question, as you can see, is feedback from water vapor and clouds. If, as we believe, the climate sensitivity is very, very small, negligibly small, the question then arises, how come? Why do the models show a climate sensitivity of 3 degrees? And why do we observe only a climate sensitivity of 0.3? What's going on? What's wrong with the models? It depends who you ask. When you ask people who are modeling, they'll say maybe there's something wrong with the observations. Yes. And we say, well, maybe there's something wrong with the models. Well, what's wrong with the models is that they cannot really capture